super, super happy that you all are here. We were founded about 2 years ago. We are 3 co-founders, met all in Germany at that time. We're all master students and we kind of got along really well, had great ideas. And that why not actually trying to work together. So that's already leading to my overview. We are these 3 co-founders. There's Kuma, Ayushman, and I. After our masters, we kind of spread a bit out. So Kuma's in New York, Ayushman in Montreal, and I'm in London. What makes working together look really easy, but we still manage somehow. And then like on the way, during the last 2 years, a couple of people joined. Rahul, who is just like giving them advice on NLP, Ricardo, who's for medical imaging and in entire like the more in the medical space, and then Pavanji, who helps with all kind of deep learning. Also 2 advisors are there. There's Professor Markus Lewicki, who's now in Sweden in Luleå, but he helped us during lots of our master's projects, so we kind of got quite close in touch to him. Some of you might not know him, who have a bit of idea from machine learning, because he had some papers with Alex Graves, who's now DeepMind and a really good guy in my opinion. So they kind of know each other. And then there's Michael as well, who is at ETH in Zurich. More kind of from a neuroscience perspective. So the entire event today will be about TextSpace. What is it here? What is our first big product? What is already in production? What we have already delivered to our first customer? And I will basically guide through the different features, different capabilities of TextSpace. And some of them you see here in the circle. I will then briefly explain how each of them works, and then also show live on our website where you can go to afterwards how these demos work, what we're able to do, and you can play with them around afterwards by yourself. Good, first a bit of an overview. So as you already can guess, we have really strong links to academia. We are all PhD students. Then we have like an advisor as a professor. Then there's also a DFKI, what's the German Research Center for Artificial Intelligence, where we did kind of internships and projects with during our masters. But that's not all. We also got a really strong link now to, luckily, to industry with our first customer, that's Geo Reverie. Some of you may know Geo. It's a mobile network provider from India. And when you just look on the total data consumption, it's the largest mobile network provider in the world. So they have, I don't know how many subscribers, but all over India. And they have like these ideas of making, like really getting Indians to the internet and getting Indians using the internet in their local languages. Because there is more than 50% of all content of the internet in English, what makes it very heavily biased, and less than 1% is actually in the local Indian languages. And then they came to us and said, hey guys, can you not work on that? And they already knew that we have quite strong performances on local Indian languages. And with the specific task that they wanted to have solved, they benchmarked us against other providers like Google and Facebook. And then actually they found out that we have been stronger in the specific task which they wanted to have. So we started collaborating with them. We have just signed like a 5-year contract, and looking forward to work on lots of different projects that they want to do. Kind of a step back, what NeuralSpace has has different projects and different ideas. There's one called what we call at the moment MedSpace. It's a really early stage project. It can like go totally wild in the other direction, but at the moment we think we use medical images, then have some deep learning algorithms that can detect how severe a certain disease is. So we don't say we take the medical image and we say there's a disease and that's that disease and so on. We still leave that to the doctor, but we say how severe is the disease in an image. So how soon needs the patient to be treated? We kind of give them a ranking, and hopefully patients with very severe illnesses can be treated then much earlier than it happens at the moment. As kind of the second pillar of what NeuralSpace does, our custom solutions, we have done that to find 2 projects. These range like from strategy formulation, where we just explore kind of the business process with a fairly small company, and then kind of try to see where potential machine learning solutions could be employed. That was very high level and very theoretical, and then they have them. They're still thinking if they actually do something. A second step we can do, or we have done already, was implementation. So companies come with a specific purpose, they have set projects, they believe machine learning can solve that problem, and then they are going to give us that task. And what is the third pillar is the training. So we have, since we are all kind of related to academia, we should be at least fairly good teachers. So we can also do some kind of workshops and trainings, or can just be like consultation in form of what our products can do. But why we are here for is actually TextSpace. So that was our first idea that we had when we just worked on student projects. We had these different features in our mind what we hope an algorithm can do related to text understanding, and then we kind of concatenate them all and build a framework out of that is very flexible, and you can build lots of different products very quickly with it. So we call it the multi-purpose platform because it's not one product that can do one feature. It's kind of a framework that is that allows you to very, very quickly develop some products with all kind of different features. And some of these features, there are intent classification, where we kind of detect the intention behind the sentence. We have summarization, where we can put in a document that is whatever long, can be multiple pages, and then you say, okay, I would like to have that summarized in 5 sentences. And then we give you an output of that entire text summarized in 5 sentences. There is named entity recognition, what means that we then recognize some certain entities and certain words in the sentence, and yeah, it just comes out in our classified. Then we have the neural machine translation, what is kind of like Google Translate, but it can also be customized to specific data sets, and so on. There are lots of other features, we are still adding them, but what I show you today are these four features. So let's start with an entity recognition. There are some standard and some custom entities. So the standard ones are just quite simple ones. There's location, there's time, there's person, there's organizations. What else do we have? I think size, numbers, and so on. Then you have some custom categories that you can add, and they're really quick to add and very flexible. So you can add on anything from brand to from different furniture, different medical codes, any kind of entity that could potentially be important for a product for you, you can add. And then the algorithm is able to detect these entities and give it out to you in a quite nice format that you can then further process. And I think we kind of do that interactively, so I explain you something, what's like the feature, and then I will directly show you on the 2 big screens how the feature works. So let's get So you are very welcome to try also by yourself. And that's our website. And you go here on the top on demos, and then you are redirected to another website where we have all our demos employed. Yeah, and that's the website. So we have at the moment 3 of them. The named entity recognition, the neural machine translation, and the summarizer employed in that website. And in another one that I'll show you afterwards, we have the intent classification that is really nicely done in the graphical user interface. So you have, it's really easy to train and it's really easy to try out. Okay, so here when you just click here, you have all the different languages that we support. They're not at the moment not all employed, so we have 35 different languages. Especially where we are very strong are what we call rare languages. So these are the languages that have not a big data set. There, for example, Hebrew is one that's not very big. The Scandinavian languages, they usually have very small data sets. English is, of course, a big one. English, German, Spanish, French, they have all really big data sets. And in these tasks, we are not as good as big providers. But then when you look at the small data sets, what are the local Indian languages, Hebrew, Korean, and so on, we actually perform really well. So I would say we first look at an English example, and then later on, like if you guys know some languages that maybe not many people know and we support them, it would actually be quite fun to try them out as well. So how it works is that we have here like we give you some examples that you can try, but you can also like just type in here anything you want, and then you just click on pass, and then it's kind of processed and comes out. So after we do that example first, so you just click on it, click pass, and then trace a little bit, and then it comes out. So the example was, on Tuesday next week, I want to go on a long drive of 500 kilometers in New York. So we find New York is a location, log, this is a signal for location. We find on Tuesday next week, so it comes the date back. We don't give a time, otherwise we would even have a time written down. It's the exact date, what is next Tuesday. And when we even go further down, we have 500 kilometers, it's inch, it's the distance. Okay, so we kind of get these nice outputs, so they're directly recognized as some certain entities. So it could work really well for a navigation system where you just speak to the navigation system, I want to go to that in that location, and then it directly recognizes that's the location, okay, that's where I want to go. Does anyone want to try a couple of examples? Tim? Come on.
Let's see. Or Felix is going to show me how NeuralSpace works.
Yeah. Yeah.
Or else.
Okay.
Okay.
Good. Yeah. So just click on pass, and you can Felix as a person. Tomorrow is on the 27th of November, and then let's see if we recognize actually NeuralSpace as an organization. No, we don't. Okay, we have a couple of organizations, so we can that was just like scrap from the web, really like all kind of different organizations. So we can here have instead of NeuralSpace, we can have Facebook. Facebook, exactly. Sorry. Oops. Good. Okay, so that should bring us back. Facing is gone tomorrow. I'm not even Facebook then. Okay, yeah, but almost. We had like Imperial, they took a couple of examples that are like big organizations, so it should actually find Facebook. Whatever, yeah. Does anyone speak a language that is a bit rare, or maybe not, like not English, German, French, and so on? Anna, how do you speak?
Mandarin?
No, you speak Mandarin. We have to. We probably have. Yeah, we have Chinese. Here we go. Good. Can you type on a normal keyboard Chinese? Really, that's perfect, right? So we have these two examples, but I'm not sure. I don't know if you can type with the keyboard. But we can just try one of the examples.
Yes, for you to do it, just open Google Translate.
Yeah,
just open Google Translate.
You want to? Let me just try one of the examples. No. Well, let's just try one. Let's try. What does it mean?
2 months ago.
2 months ago. Okay, good. Yeah. So from the would be the 1st of December to the 1st of November. Good. Okay, good. So we recognize months. Yeah, and we do that in 36 different languages. So can range then from any kind of small phrase that we have here from these 2 months to long sentences that we then recognize multiple entities. Good. That was the first I wanted to show you. The second is very different. It's neural-machine translation, but you can kind of understand that as Google Translate. It's not that special thing, but we have also, like what I said, these rare languages, what is something quite special, and we can customize it. So when you have, when you already know what kind of purpose you want to have the translation for, then you can customize them. That can then work really well. So instead of having like Google Translate, just like a generic translation machine, you can have that on that, like trained, of course, with some generic data set first, just to have like a general understanding, but then all with some custom data that gives you a quite precise answer for these technical terms or something else. So I will show you on the website again, just NMT with neural-machine translation. That's, by the way, all live, so you are welcome to try them out at home. At the moment, we have only one model employed. That's from English to German. But yeah, and there is like that example that comes from an insurance policy where it's written, this plan provides for automatic increased risk cover after every 5 years during the term of the policy. So it's not that easy, English probably, and yeah, since I'm German, I know that the translation is not too bad. Politik is like more politics instead of policy, but otherwise it has performed quite well. So we also give here a couple of different translations, and then we have a score, and the higher the score, the better the translation. Or the closer the score to 0, it's always a negative value, the better the translation, according to some kind of certain network, some kind of certain data that we have trained it on. So, yes, that was the neural-machine translation. I would go on to the next example, what we have spent quite a lot of time on, and we really like that. It's summarization. So you, as I said before, you can give it any kind of input, or it can be any kind of document, can be multiple pages long. You say you would like to have it as a summary with certain amount of sentences, and then you get what we say, the main ideas, the most important content. So when you want to try it out, you go to summarizer here. Again, we have here the same languages that we provided in the entity extraction, and then anything here. So now that's a fairly small example that we have already here, but I would say we try out something else. Let's go to some kind of website that we can try about. BBC. Jesus. So let's do the BBC reports. Okay, so let's mark on it here. Okay, that's very small. We can try. Good. How many sentences do we want to have it? 3, 4? So it just processes the data, and then you see here the main text and summary. So an interview. 4 times per year. Okay. Yeah, it's actually makes perfect sense. So first it says he's asked, and then Mr. Corbin replied, and then then there comes a quote. So it is, according to our model, the most important content of the entire text that we pass in. So we already try what we've done to try to make actually sense throughout. So it's not just like sentence, sentence, sentence. We kind of try that they are connected somehow to each other, and that they can that then give like a kind of story that is still the same content. Okay, so when you are on our website, you can also click here on API docs. What I really was just a Postman, and then when you whatever kind of solution you have, you can try out the API here. That's your API key, and then you can like call our solution. Then the processing happens on our side, but you get with the output. That's all online. Now you go on our website and you find all the API key. Good. The last of all features that I'll show you is the input classification, where we kind of understand, like to some level, we call it natural language understanding and not anymore natural language processing, because we kind of get a little bit of intentions behind that. And that's what people have already called understanding and not only processing. But yeah, it's a vague thing. So you do that. There's also a link in our website. It's here in TextSpace. So that is just like a graphical user interface that we made that allows you very quickly to try out your different intents. So we have here on the left, on your right, kind of a chatbot window where you can quite easily test if your solution actually, or if your intentions actually are recognized. So there's an agent, so that's kind of a chatbot, you can imagine it, and I already pre-trained one, called Pizza Agent, because as I said, okay, maybe like Domino's Pizza, actually you want to order something, you want to have some questions, and so it's just quite an easy example. We have here the different languages again. There are totally different languages you can choose. The threshold is fairly, you choose in the middle, that's actually okay. And then we also have some fallback before. So you can, just type in, and when you have some sort of input that our chatbot doesn't understand, it falls back to normal flows. So they say, can you repeat it please, or can you can rephrase that in some way. All right, so each agent has certain domains, and I just pre-trained here 2 domains that are pizza, FAQ, which just means opening times, and on, and the pizza order. So when we click on the pizza FAQ, we see all the intents that I've already made. So like opening hours, what kind of pizzas you have, and so on. You can really easily add some. So you just click on the top here of create intent, and then you can add a new intent, and it actually has one more capability of what it can recognize, what it can understand. So I will then give it a try and say, load, and then I'm a bot, I can answer a question and have you order pizza. So, and then you can ask kind of anything, what you have covered. So that's actually, that's your user, right? So you have kind of a really quick trial, what a user will be and how a user will get responded. And here you can add anything that is like from the domain to the entity, to the intention, to the entity. So the entity recognizer we had first on the other website, we have also here. So you can have actually, you can also add your new entities. And then you can say, I'm a bot, and answer pizza, what you like. I should still open. And then should come response. We are open 24/7, wonderful. Okay, good. So we can order pizza. And I order. So and then it's just gives you which pizza do you like. Then you go through that, and then you say, what do you have? And it should then find kind of the different pizzas that you have. So what makes that into classification kind of powerful is that you don't need to phrase it as said, right? You maybe have seen when you use Facebook Messenger that there are some bot buttons actually. So whenever you chat with a bot, they're very often the buttons that you need to press. So they give you already the answers beforehand. But then when you actually want to ask something else, it's not part of the button, you're stuck, right? So with that instant classification, it's not defined to some certain answers. It's just you can type as you want, and then it becomes, and it understands to some extent the intention behind, and actually knows what you want. So we can have here, what kind of pieces do we have? Java. And let's see what else. Okay, then ask like how many pieces we want to order. Let's say 9. And wonderful. For all of my pizza network. Okay, good. And then you can, so we gladly don't keep they buy and so on. Thanks a lot, man. So it, yeah, that's like entity extraction, of course, right again, because we have a number here in a directly extract 9 numbers, and then you can actually, when you have, for example, dominant pizza system behind, that directly puts that in without having a human checking how many pizzas need to be done. Yeah, that's quite easy to do here, and really quick to train out, to check out. And what we find, yeah, so all that stuff is based on a technology that we have like partly developed by ourselves, what we call semantic caching. There has been a couple of publications about that in conferences, but yeah, it has all been done by ourselves, and we are kind of really happy and proud to have that. What we find, also another really good argument, I can just show that as well, that you can kind of retrain with a new intention, with new entities very quickly. So normally you may have seen that, the people who know a little bit something about machine learning, that you need normally like massive amount of resources. So it can take multiple days to train a network. You need like 5 computers, each worth 10,000 pounds, and then you can actually get state-of-the-art results. But what we do is something quite different. So we don't put all the emphasis on building a good neural network. We actually put the emphasis on having really nice pre-processing of the data, so it can be trained within 10 minutes or so. And that has been working quite well so far. And we actually, yeah, looking now specifically into mobile devices, because we see like the future of our product kind of in devices that are not connected to the cloud. Because when you use Siri, when you use Microsoft Cortana, Windows Cortana, or whatever, you just speak into your phone or into your laptop. It goes to the cloud, somewhere it's processed, and then the response comes back. But what we do, you speak into your device, all the processing is done on your device, and it comes back. So that's kind of a nice feature that we believe could be very helpful in connections that are not well connected to the internet. What could be, for example, a driving car, could be your mobile phone sometimes when you don't have the strongest internet or don't have Wi-Fi, and so on. So, shall I add a new intent? Is anyone interested in seeing that? It goes.
Yes, please.
5 minutes. Okay, good. So, okay, so we go on intent. Oh yeah, we. Good. Then I can create a new intent. Just click on here. We need to choose a domain, so it's like an FAQ or it's an ordering. Any preferences? No, the FAQ, okay, let's take an FAQ. It's a name, what we call it, we say weather. Weather. Okay. So user that's actually where you give your training examples. And normally, when you may have read deep learning literature, you need like thousands of images, right? So there's a popular data set in deep learning that's called MNIST that has 60,000 images as examples. And they are only the handwritten digits from 0 to 9. And there's 60,000, then you get a fairly good accuracy. There's another data that is called ImageNet, that has, I think, more than 100,000 examples. So it's like, you normally need a massive amount of data, and that's why it costs also so much computation to train it. But I give here now for the weather, we can give like how is weather good. Is raining today? And Okay, so these are like 5 questions a user may say. So just like 5 potential examples that the user asks for how the weather is. Then we can also add some keywords and slots and all. That's not too important for now. Yeah, agent response, and then we can have some certain response of the agent. So we say today is very warm. Today is very warm. This is just what the agent will respond now. And then, yeah, you can also define here some webhooks, what means when actually, whatever input the user brings, it can be to a webhook. So it can be, for example, your Domino's Pizza server where you then just directly input the number of pizzas and what kind of pizza they have. So that's all. You just then click here on create, then at least one feature. Okay. Just click here on create. Then I see here it's our trade. Okay, like the last time train was 23 hours ago. I just click here on train. Takes a minute of time. So what it does, it takes these 3 example sentences that we have and then kind of projects them into some, you can call it high-dimensional space, where lots of similar phrasings of the word are also very close to these 3 phrases that I gave. And so you kind of then recognize directly that all these sentences that kind of mean the same, and they're all very similar to each other. But that needs a bit of time to get all the data that I'm already finished. So I do click here on reset the session. We can also record here. So what is we also have speech to text. So when you click on the microphone here, you can actually speak, and then it should be able to recognize what we say. So I can give it a try. Should be connected to my laptop, hopefully. What is the weather today? What is the weather today? Wonderful. So today is very warm and sunny. Yeah. That was one intent I created. And it works at the moment really well for English. Especially speech to text doesn't work that well for the other languages because we just don't have that much data amount to train on. But for English it works really well, and I think that most applications are pretty okay.
Is there any variation in the output, or is that always the
So that is, you can add some kind of entities that then say, okay, when today, then actually you can call the weather information actually of the day, and then you can set in according to that. I just have here like a.
But if you asked it again, would it give like a variation of the same response? Or
Can I do it now again? No, it's the same response. Alright, that was just like really quickly adding one intent without, really simple, without any entities inside, and just retraining the network for whatever, say a minute or 2 minutes, and then it's ready to be used with all other included, of course, because we don't lose any information from the before one. Yeah.
So, when I played around with the Alexa interface, this looks very similar to the Alexa interface.
Yes.
So, what is different?
The languages.
Or is it two stupid questions?
No, it's not sure. The languages that Alexa supports. So, I'm like after that I will show you a use case of Geo Reverie, the customer that we have in India, and they actually want to build something that is very, very similar to Alexa, but in the Indian languages. And so that is something what we can do a bit better than Alexa at the moment. Yeah.
There's something like 11 languages which is split over India, right?
More.
Do you support like all of them equally? Or
Yeah, we support 11
actually?
Indian languages. These are like the main 11 Indian languages, but there are in total more than 20, I believe. Cannot be more, right? Probably like whatever, like 40 or so. But the 11, what are also, I believe, official languages. So in the different states, I have English, Hindi, what is like the main Indian language, and then have plus one local language, which are official languages. And we support all of them.
How do you compare to benchmark in Hindi? To like the benchmark of performance of these tasks? Is Hindi counts as a rare language, or is that?
No, Hindi is not a rare language. Because the data set,
Yeah.
it's not that big, but still a bit bigger than the local one. Yeah, so I would go back to yeah, good. And we'll speak a bit what we actually do with the learning here. So we are like in a 5-year co-development agreement, and what especially what we focus on is kind of what they call democratizing the internet. So as I said before, like more than 50% of all internet content is in English, and they want to translate them into the different languages. And I will show you a bit of a small video here. So yeah, these are the different states of India. So they use TextSpace as kind of an underlying framework. They have developed the product on top of it, and they translate all the internet. But the underlying framework that they use is TextSpace. As you see, like 56% is English and 0.9% is only Indian language, local languages. And that's what makes lots of people in India really difficult to connect to the internet, because they either don't speak English or they have like, difficulties in using actually Indian English language. So they have kind of then employed their solutions to any kind of different things. So they have like translated Google Maps. They have like a user on e-commerce platform that they supported, and so on. And they call it language as a service, so it's just like actually kind of a layer on top of a website that translates. So you may have seen that you can actually install a Google Translate kind of plug into your browser that translates any kind of website, and they have done the similar for the Indian languages. Yep. And yeah, Bharat means India if you don't do it. Good. So yeah, and that was actually it.